Well, I thought I'd give another quick update. Basically, as you can see here, I put an arrow to where I put the control lines in now. So the white lines are the control lines leaving out of the multiplexers down at the bottom. And now I should be able to control just about everything on the right hand side and a couple of switches on the left. So at the moment I'm using the right hand EEPROM, and the left hand EEPROM still isn't wired up, but that'll control everything on the left hand side. But at the moment I'm focusing on the right hand side EEPROM and that blank board, which is going to be the memory or constant register. So that'll be the memory connected to the memory bus. I got a stick of memory, a static RAM, and I'm programming it with the Arduino. So the idea here is that I program it with the Arduino. I can stick it in this board. I needed to test it, so I've got a timer and a couple 390 decade counters to increment through the 8 addresses one after another. So I wrote this sketch that basically puts random data more or less into the pins. I had to change it because I had the right pin high, so I had to disable the pin until after all of the other pins are set, because it wasn't really taking everything properly. But as you can see here, basically I have a write to SRAM function, and I'm basically setting the digital write low. Then I set all of the pins for the addresses so that it's going to write into the correct address. And then the second for loop is to write the data that I want onto the data pins. So there's the timer, and then the decade counter. So you can see that doing a binary count with those lights. And then I've wired them all up here, and then the output is basically random binary stuff. But this is a lot easier than the EEPROMs because I don't need to erase them with a UV light. I can just run it from memory. So here's the EEPROMs I'm using, and as you can see, they're EEPROMs, so they're electrically erased, but I have to use a UV light. So this is now into the software where I'm basically trying to update the opcode. So on the side here you can see the opcodes. I've changed this recently because I initially thought I would use the top or most significant 4 bits as the opcode and the other as a constant, so I could put in move into register 1 3 or something. But that didn't really work out very well. So what I've decided to do is just use all 255 opcodes, one after the other. And where I've got a constant, like at the top there, I will just put that as a second instruction to get that value out of memory. So I've got a load that I haven't done yet, knots and XORs and all sorts, and that isn't including any of the store or load or any of the other stuff that I need to complete all of the opcodes. So the reason I started now was because it was easier to use the EEPROM to flip on and off the latches and the switches in order to test it. So over here I've got 2 types of EEPROMs that I can write, 1024 and a 2048, but I'm mostly using the 1024s at the moment. And I write to 2 EEPROMs. So the reason for that is what I've done here is I've defined it as a 32-bit rather than 2 16s, because I'm masking 2 different ones. But the first bit there was for that first multiplexer. The second one is for this multiplexer. And then the third one is for this one, which is a 1 to 16 multiplexer. So that does all of the latches and any of the assertions onto the data bus. But down here, this is for the second latch, the second EEPROM, which I haven't really done anything with. I've got a couple of placeholders in there, but it doesn't output anything at the moment. So the plan is to basically start to fill all of this out as and when. But at the moment, I really just wanted to focus on getting the lines, the control lines, active when they should be. So here I got a write binary, so that just dumps out the file, and it dumps out two files. So the first one is 0 bits, and the other one is shifted 16, so that, as you can see on the other side, when it writes to the second EEPROM, it'll have an EEPROM bin file that is basically the top most significant 16, and the other one is the least significant 16. So that all works. I don't have any flags at the moment, but it's in there if I need it. I will eventually, because I'm going to have compare to 0 and all that sort of stuff. And then I have a massive instruction function. So what this is doing is basically take no op, which is 0, or it maps the one I'm looking at here, the move R1 to R2, and then it masks the correct values for going into the EEPROM. So the EEPROM bits on the right there, they basically represent the pins on the EEPROM, and so that just outputs, when I need it, out to the EEPROM, and then highlights the things I need. So I've been doing a lot of this in software. Here you can see the dump of one of the register files after I've generated it, and basically the hex numbers. I'll just quickly go over this again. So this is the breadboard, but I've got some problems with it. The display at the top left still doesn't work. The program counter, which you can see in the top, that's basically broken, needs rewiring. So there's a lot of problems, and I still need to do a lot of work on what's left. So still a long way to go. I need to get the constant register working. I need to rewire the program counter. I need to get the control registers working. I need to get the reverse clock working. There's a significant amount of work left, but things are coming together, and it does help keep me occupied. I am doing other stuff at the same time, so I'm not really spending full time on this, but it does consume a lot of time, and it's a pretty good lockdown project, to be honest. Yeah, so the main things going forward are to get the memory register sorted out, get the control registers working, rewire the program counter, get the digital display working so I have some sort of output, and then in future I need some way to input things, so I'm going to need a UART, for example, for sending information in and out. So yeah, a lot to do, but it's pretty interesting, pretty involved stuff. Be interesting when I get to the writing an assembler and a compiler for the thing, but I'm a long way from that. I've still got to finish all of the ops codes and the machine codes. Alright, well, I hope I haven't bored you too much. See you soon, hopefully, after all this lockdown crap is done. Bye.